Let us look at what is a dihedral angle. So, a dihedral angle is the angle between two intersecting planes or half planes. So, here atoms ABC is in one plane and atom BCD is in another plane. So, what are the atoms ABCD what we are talking about here, we will look at now. So, this is atom A. So, this is atom A and this is atom B and this is atom C and this is atom D. So, these are all the 4 atoms, and with respect to these 4 atoms we are going to talk about what is the dihedral angle. So, there are 2 planes which are formed, one plane which has atom A, atom B and atom C. Basically, this is given by this particular pink frame. This is basically the plane which has all the 3 atoms A, B and C in one plane, and we also have another plane where B, C and D are present. So, these are all the 2 planes we are talking about, and the angle between these 2 planes, this is basically the 60 degree, and this is what is called the dihedral angle. So, in other words, the atom A and atom D are the 2 atoms for which we are talking about, and how these 2 atoms are actually present. Based on that, we are going to tell about what is the dihedral angle, and the dihedral angle formation is based on 3 atoms A, B and C, all the 3 atoms in one particular plane, and we have another plane B, C and D. Basically, both B, C and D, they are in the same plane. So, the angle made between these 2 planes is called the dihedral angle, and whenever we talk about conformational analysis, we will be talking about this particular dihedral angle. And if we look at 4 different atoms, say for example, we have an atom, let me put this as atom number 1, this as atom number 2, this carbon as atom number 3 and this hydrogen as atom number 4. So, we have 4 atoms. So, any 3 can be in one particular plane. So, that means 1, 2, 3 are in one plane if we assume that, and atom 2, 3 and 4 are in the second plane. If we assume the bond angle between these 2 planes like 1, 2, 3 and 2, 3, 4, the bond angle is 0 degree. So, in other words, this is actually called, in this particular case, the atom 4 and atom 1 are in the opposite direction. So, here instead of 0 degree, we call this as a 180 degree. So, the difference between these 2 angles are 180 degree, because this is the same plane, single plane, and that is the reason this is called the anti-arrangement. So, the staggered or the anti-arrangement, we have 180 degree as the dihedral angle. And when we talk about eclipsed conformation, in the eclipsed conformation, what will happen is, there is one atom at the back, it is attached to the carbon atom. Let us say this is hydrogen, this is attached to the carbon. There is also another carbon atom in the front, and that is also having a hydrogen atom. So, if these 2 are in the same plane, when hydrogen and hydrogens are on the same side, we will be having 2 types of plane. That means, hydrogen atom, let me put as 1, this carbon as carbon 1, this carbon as carbon 2 and this hydrogen as hydrogen 2. So, that means, hydrogen 1, carbon 2, they form one plane, and carbon 1, carbon 2 and hydrogen. So, they form another plane. So, the bond angle between these 2 planes is, because here they are on the same side. So, the bond angle between these 2 is 0 degree. In other words, we call those type of arrangements as a eclipsed conformation or eclipsed arrangement. Let us look at the molecule, and we will understand this little bit better. So, here in this molecule, as we mentioned earlier, one hydrogen, there is at the back we have a carbon, and front we have another carbon, there is another hydrogen. So, if you go with 1, this is 2, this is 3 and this is 4 atoms. Between these 4 atoms, 1 and 4 are in the opposite direction, and the dihedral angle between these two planes 1, 2, 3 and 2, 3, 4 equal to 180 degree. So, this is what is called the staggered arrangement, and in this particular case we have hydrogen 1. Let us say this behind hydrogen, let us mark it as 1, and there is a carbon behind. So, this is carbon number 2, there is a carbon number 3 and there is a hydrogen number 4. So, here again that 1, 2, 3 is one plane and we have 2, 3, 4 as another plane. So, the bond angle or the dihedral angle between these two planes is equal to 0 degree. In other words, this is called the eclipsed conformation. This is a staggered conformation. So, due to rotation, the ethane molecule can move from eclipsed conformation to staggered conformation, and during the process what we are doing is we are actually pushing one of the hydrogen towards or this particular bond, the carbon carbon bond, that is between carbon number 3 here and carbon number 2, we are actually rotating this single bond, which leads to various arrangements or various movement of the behind hydrogens. So, that is how we move from hydrogen here to hydrogen this place. So, like that we can keep on rotate the molecule, that is one particular single bond is rotated to make different types of arrangements, and these are all called the various conformations. And here the difference, or there will be a little bit strain in the eclipsed conformation. So, we call those kind of strain as torsional strain. The torsional strain actually occurs due to the non-bonded interaction between the two eclipsed, because this hydrogen in the front and the hydrogen in the back, they are not bonded to each other. So, when the non-bonded hydrogens are placed one after other or eclipsing each other, then we have something called the torsional strain or bond opposition strain. So, this is one called the torsional strain.